Hi, good afternoon. It's Gene from Maverickstar Observatory. I thought we'd do a little bit of theoretical science today, and on that basis we're going to be talking about maximum momentum of inertia. Interesting topic. And the reason why we're going to be doing that is because I've been doing a little bit of thinking. Obviously it stems from the magnetic pole reversal. It's got something to do with the earthquakes and major activity across the equatorial region, and some of you will probably understand where I'm already at, but some of you won't. So maximum momentum of inertia happens around the equatorial region. If the maximum momentum inertia wasn't there, then this Earth would probably tumble on its all four axes. So the reason why we enjoy a nice rotational constant spin around the equatorial region in 24 hours is because of the maximum momentum of inertia at that region. Okay, so where are we going? Okay, so what I was thinking about earlier on today was what would cause the Earth to flip over. What's described in the Bible. The Earth weighs to and fro like a drunk, and it has been accepted by people like Albert Einstein and a few other famous scientists that it is not quite impossible for that not to happen. So there is a possibility, very slim, but it is a possibility. I will show you later on in this video what happens when things are not at the maximum momentum of inertia. You probably remember a few years ago, or maybe a year ago, I showed you what was happening with a strange anomaly that was taking place in space. The Russians were the first to discover this. They classified it for 10 years. This was when an unbalanced object, I'll give you a classic example. If you know what a wing nut looks like, if you rotate that in space, it will spin one direction for a few seconds and then turn around 180 and spin the other direction, and then it'll do it again the other way. And what makes that possible is a change in the mass over the center of maximum momentum inertia. So if you're looking at this little map where all the volcanoes are, if we added mass to the top of the Earth by perhaps 15%, then what we would have is that exact same effect of it spinning on its axis for a few seconds and then reversing completely 180 degrees and spinning on the opposite axis. Now, first of all, I'm not surprised. All the volcanoes and major earthquake activity takes place around the equatorial region, and that is because of maximum momentum inertia. We could change the maximum momentum inertia by moving a lot of the ice from the one pole to the opposite pole and increasing the mass over the northern hemisphere by about 15%. We would get that same effect. I think before we go any further, it's worth just showing you what happens when things are out of balance and we don't achieve maximum momentum of inertia around an equatorial region of an object spinning. Let's do that. So we're on board the space station, and the astronaut is about to approach that T-bar with his hand. I'm going to start the video in a minute so you can see it. He's going to rotate it so it comes out of the nut and then starts to rotate in free space. But just watch the behaviour of the nut after he does that. So I think you get the idea. I think I'll just find one more example for you so you get a clearer picture of what we're talking about. So here's another good example, again on the International Space Station. At this time the astronaut has formed a ball of modelling clay but stuck a big nut on the one end, and it's created an imbalanced force over the rotation of axis, and that offsets the maximum momentum of inertia. And when that happens, same thing as the T-bar or the wing nut that we just saw spin off out of the nut holding, you get the same effect. So let's just play the video so you get an idea. So it rotates over its axis and goes back again. So let's get back down to what is taking place on Earth, and I have to say it's not too dissimilar to what we was just watching in the ISS. Because we are a body that is rotating in space, the Earth is just simply like that wingnut, a body that is rotating in space. The only thing is there's a lot of fluidness on this Earth, which means that things can transfer from over one side of the equator to the other. I think we're witnessing one of those things, and you know, we talk about the magnetic poles on this planet creating the North Pole. We've seen that it can regulate where the Arctic poles are on our planet. So we've got Antarctica and the Arctic Circle, which are the coldest regions on our planet. I don't think there's any coincidence that they are on the rotational axes. Up until recently, we have had a pole very close to the centre of rotation on our planet, which is migrating towards Russia. So what is my point here? Okay, so we've got the coldest regions in the same location, we've got the magnetic dipoles in the same location, and we've also got the rotational axis in the same location. Is it coincidental or is it synchronicity? Are they all connected? And I think they are. And that one of the reasons I say I'm not surprised that over the equatorial region we get most of the erupting volcanoes and earthquake activity. That's because that's the area of our planet which is at most risk from centrifugal forces pushing out on that rotational axis or the equatorial region. So that's where you're going to get a lot more activity. It's going to be a little bit more calmer over the northern and southern hemispheres, and that's probably why the dipoles are where they are. So how do we get then a situation where the poles, or sorry, the rotational axis splits, or sorry, not splits, rotates 180 degrees? And just like that wing nut and that modelling clay with the nut in there, it also tells us how that is a possibility. Now I'm going to talk about one feasible idea, which is a transportation of a conglomerate of ice over the northern hemisphere that outweighs the southern hemisphere. So if we've got a zero net over the southern hemisphere in the Antarctic, and we all of a sudden end up with 15% more ice in mass over the northern hemisphere, that could set up the same anomaly that we just saw taking place in the space station, where there's an imbalanced force over the rotational axis. That's one thing. But there's something else taking place. We're going for a magnetic reversal, and the material in our core is not without mass. So if we are seeing a shift in the mass of the material within our core, we therefore see a migration of the magnetic pole, which is an indication of something changing within our core, which generates the magneto, and in turn the magnetosphere, which protects us. But if we go a little bit further than that and just think of the simple principalities of what is taking place in our core, there is mass moving from one location to the other, and therefore this could be a scenario that sets up a similar effect to what we saw happen in the space station, of a transfer of mass, of imbalance from the southern hemisphere to the northern hemisphere, or the northern hemisphere to the southern hemisphere. Doesn't matter. If when you get an imbalanced force over the rotational axis, because the rotational axis usually is where all the mass is, and I think you'll agree with me, there's a bulge of ocean around the equatorial region which could shift if the rotational axis shifted. That would cause major catastrophes. But this is the point. It's not impossible to achieve. And I've said this before, I don't believe that those three things over the north and southern hemispheres are there by accident. And I'm talking about the coolest temperatures on Earth, the rotational axis, and the magnetic poles. I think it is all part of the mechanics which play a part of each other, and if we start to see changes in those, then or two of those things, and we already have. We've seen a shifting of the Arctic pack over the northern hemisphere, migrating in the same direction as where the magnetic North Pole is, towards Russia. Russia is going to get colder in the future as a result of the magnetic North Pole moving over that direction. But we've got the rotational axis, and it hasn't shifted yet. And that doesn't mean it won't do in the future, because all the magnetic pole is an indication of the movement of the interior of our core. And if the interior of our core is shifting, and therefore the mass is shifting, it's only got to shift to a certain degree in order for us to get a rotational axis change on our planet, or our orbit that we enjoy and have enjoyed for thousands of years. So it isn't impossible. You've seen that by the experiments done on the ISS, and we will continue watching and observing as these changes take place. Now, one indication, the reason why we're looking at volcanic activity, because if things are changing in our core, we are going to see volcanoes that have been dormant for thousands and thousands of years start to erupt. And when we do, we know that there is a further shift in whatever internally is in our core, and that could then start to alter the rotational axis on this planet. Now, you've seen how fast the rotation takes place. It spins several times in one direction, then flips over, spins several times, but the rate at the flip is very fast. If that happened on our Earth, well, you can just imagine at the equator region of our planet, there is what's called a central bulge of water. Well, that would shift, and that could engulf continents. It'd be like, I don't know, 1,000 metre, maybe more, 2,000-3,000 metre tidal wave coming over a continent as that happened. It would be quite possibly a near extinction level event if that took place on our Earth. And today that it is very possible, and we probably are aligning ourselves up right now for that very thing to happen. I'm not saying that it could, I'm just saying that there is the theory in which it could take place. So there are a couple of possibilities. We have a massive accumulation over one hemisphere, more than the other, about 15-20%, and we will get that reaction that we've saw. Because what we're doing is we're imbalancing the maximum momentum of inertia if that takes place. And again, just because the poles are migrating doesn't mean that there's nothing else taking place in our core of our Earth, because it is an indication exactly of that. There is a mass movement of material in our core, which usually rotates in one direction and sets up our magnetosphere that we enjoy right now. But as we know, we've lost 20% of our magnetosphere, and this effect could continue changing the interior of our core to produce an imbalance over the rotational axis, and therefore we won't no longer enjoy a maximum momentum of inertia around the equatorial region, and we could see our planet behaving just as we did that wingnut and that modelling clay. So guys, I thought, why not give an example of how something is possible, and today that was what it was. This is how a complete 180 flip of the actual rotational axis could happen, and as we found out, it is not beyond the impossible. Guys, there's a link down there if you enjoyed the video. You want to help support what we do at this observatory. We're mainly interested in monitoring the anomalies that are taking place with relationship to the magnetic North Pole on our planet migrating, and the increase in cosmic radiation. That's what we do here at the observatory. If you want to support it, if you've got a couple of £1,000 sitting there in your account and you've had that there for many years and you don't know what to do better for it, why not donate it to our observatory? There are worse things, guys, than supporting an observatory, especially independent observatories, because that's where you get the truth from at the end of the day. I hope you agree. Guys, have an amazing day. So what I usually do. As always, bye for now.